Okay, continuity and in behavior. If I were to give you a graph of f, and I said, is that function continuous? Yes or no? Raising that yes level of power vote here. Yeah. Who thinks that function's continuous? Okay, now it's a popularity vote. Well, everybody else is raising it. Who thinks it's not continuous? All right, good choice. Those of you that didn't vote, you're lame. It is continuous. Why?
Because there's arrows at the end.
Okay. No breaks.
I have arrows.
Has arrows.
Okay, we would say f is continuous because there are no breaks. Okay, that's conceptual. If you draw it, you don't pick up your pencil, right? It's just a smooth flow, done. If you have to pick your pencil up in the middle of it, it's probably not continuous. We'll call that G. Continuous, not continuous. Okay, we call that actually discontinuous. And we would say at some C value. Okay, we would actually list where it's discontinuous. All right. So G is discontinuous at x equals C. C is just some number. Okay, that's easy enough. Okay, that's what it is. That's the picture of it. There are a few types of discontinuities. Does anybody know what the graph of this looks like by chance? Probably not.
I'm gonna say
Your feelings serve you correct this one time, my young Padawan.
I'm again for that.
Lord of the Rings. What is it like?
That is called an infinite discontinuity. Okay. Because they go to the infinite. Yeah, I had to pick up my pencil. How about this one? This is part of your. Where? You're close. -1. How'd you know that? Okay, so on the bottom, -1 + 1, 0, right? So at -1, something's happening. It's a whole because the top has x + 1 in it as well if you factor it. If the top did not have x + 1, it would be a vertical asymptote. All right? FYI. We'll get to that later in the year, but FYI. So this is called a jump. No, sorry. Point discontinuity. Dang. And one more. Let's do a piecewise function, huh? Shall we? Piecewise functions are going to keep coming up and haunting you. Okay, so you might as well get used to doing them right. Okay. So we have this function, x squared plus, okay, that's not what I graphed. 1, we'll just make the easy change. Okay, so the y-intercept is 1 and it's x squared, but it's only below 0, that direction. So it's just that half of the parabola. And then the line y equals x from 0 above. This is called a jump discontinuity. That's funny. White men don't have jump discontinuities. Get it? That would be Mikey. Thank you. You're funny. Okay. Are you good with the definitions? Okay. The next part is determining if a function's continuous. The definition. Let's pick. You want an easy one or a hard one?
Wait, is the homework gonna be hard? Wait, yeah, actually do a hard one. You don't know how to do a hard one.
We'll do a piecewise function.
But we don't know how to do an easy one though. Maybe the homework's easy, maybe the homework's not.
If we do an easy and a hard one?
We'll see what happens here with this one, and then we'll go from there. So we're just going to test it at a point, x equals 1. Notice that that's right where our piecewise function transitions between the two. So this is a pretty classic problem to test for continuity. If there's our first question. Is f defined at x equals 1? Which one are we going to use? Which one is equal to 1? Okay, this one has the equals in it, so we're going to use, and we're just going to evaluate it at 1. Does it check out? Yes, it does.
it gives us a number. If you get like divide by 0, would that be okay? No. Okay. Any errors, divide by zeros, negatives, and square roots, those do not work. So, but this one does. Okay, the second part's the long part. As x approaches 1, what happens to the y value? That's what we're asking. From the left and from the right. So on the first one, we're asking, does that point exist? And then on the second one, we're asking, what happens right next to it? So we're establishing that there's a continuity around that point, okay? The way let me draw you a graph to see if I can give you a better idea. Okay, that's what that graph looks like. So what we're saying is x is coming towards 1 from the left. What y value are we approaching? Yeah, you're correct. And as we come from the right, are we going to 1 as well? So left towards 1, right towards 1. Okay, we're coming in from both sides towards the x value of 1, right?
Right.
What y value is that coming to? 1. That's what I'm talking about. You can also do it numerically. If you want to get close to 1, that is ugly. See how I'm getting closer to 1? 0.9, 0.99, 0.999. Go ahead. If x is going towards 1, what's happening to the y value? Yeah, we use this function, right? Because it's less than 1. And you actually just get the same output. Okay, so that's the left, numerically. The right, are you with me? That's a bad sign. Okay, I got 1 box of rocks rattling upstairs. You good, Jordan? Anybody else? From the right, you get closer, 1.1, 1.01. You just keep getting closer and closer. And see what happens to the y values. In this case, it's the top function, because it's greater than 1. And I can just give you the numbers here. Are they going to 1? Yeah, closer, closer, closer. So from the left and the right. Left and right. So those arrows mean approaches. So as x approaches 1, y approaches 1 from both the left and the right. All right, so that's 2 tests. We have one more.
Not harder, dude. Which one was that?
This is the easiest one of the 3. Do 1 and 2 match? F of 1 is 1, right? As x approaches 1, y approaches 1. Are those the same? Yeah, check. Okay, so number 1, that exists. It's a number. Number 2, from the left and from the right. So it's like, imagine yourself on one side of a wall, the right side of a wall. What happens if you walk towards the wall? You get closer until what? You run into it. And if you walk from the left to the wall, it's the same thing, right? Okay, the wall is, the 1 is the wall. Those have to match to satisfy number 3.
I don't understand how we match.
Because we're both getting closer.
1 equals 1.
X is 1, y is 1. X is 1, y is 1. Right? Okay, so, and they're the same, so we would say F is continuous at x equals 1. That is a test for continuity at 1 point. And honestly, that's no more difficult than an easy one. It's a harder function, but if I were to show you x squared, it'd be the same amount of work. You just know what the graph looks like. Okay. Can I move on? No? No, just wait. Who said my name? My problem is that it's empty. Yes, it's been a very depressing day. I've gone to the bottom. Okay. The rest of this, I think you already have a handle on. I just want to go over it to make sure.
Okay.
Because I gave it to you on Friday, and it looked okay. Into behavior. You hate this. Thank you, Mikey. Jerk. Okay, so today's describing functions. So we know it's continuous. And then we got to know what happens at the ends and in the middle. Okay, so what happens as x goes that direction towards infinity?
Y
Y goes to? Do you already have a handle on this? Okay, what happens as x goes to negative infinity? To what? Yeah, it goes down. Do you think you can handle that? Okay, graph it, describe what happens at the ends. The increasing and decreasing on intervals. Would you say that this graph is increasing or decreasing on the orange? Why? But you're going from left to right. What if I'm going right to left? Okay, so we always go left to right. You got it. The question is, on what interval? Negative infinity to what? Where does it stop going up? Okay, -1 is what we're estimating.
No, that would be positive.
It's the x values. Okay, where does it begin increasing again? To infinity? Thank you, Buzz. You are a toy! A tool. What? Oh, never mind. Okay, so these are called intervals. They're not coordinates. From, okay, x negative infinity is like way out here, right? As I go left to right, this function is increasing until we hit -1. So from negative infinity to -1, it's going up, right? And then what happens? It's decreasing on -1 to 1. The intervals are dependent on the x values. And then it starts increasing again at 1 to infinity. Did that clear it up? Do you know what going up is? Okay, where is it going up? Yeah, from negative infinity to -1. So from here over, it's going up. And then it goes down from -1 to 1. And then it goes back up from 1 to infinity. I think you get it now. Yeah? Maybe. Okay. I'm going to get you started on the work, and I'll tell you which ones to start on. Number 5 is the continuity test, and 7 is end behavior, and 9 is increasing, decreasing. So start there. And I'm going to come check to make sure you're competent. Yes.